Right? So critical values, derivative is 0 or derivative does not exist. For the derivative to be 0, basically we just set the derivative equal to 0. If it's like a rational expression, looks like a fraction, in this case all we really have to do is set the numerator equal to 0 to find those critical values. When the derivative does not exist, we set the denominator equal to 0. Right, so set the denominator equal to 0 for finding when the derivative does not exist. And remember, for this, if we use the quotient rule, you can skip this. Right, so this one, setting it, the denominator equal to 0. If you do the quotient rule, you don't have to do that because the denominator of the quotient rule is 0. That means the denominator of the original function will be 0 also, which means that x value is not going to be in the domain of f, and it can't be a critical value. All right, so you get kind of a free pass when you're using quotient rule. You don't have to worry about that. Let's go ahead and take a look at number 1. So before I do the derivative of number 1, I am going to go ahead and think of it this way. You can rewrite it or just think of it this way. X squared minus 3x plus 2 to the 1/3 power. So when I do the derivative of this, I'm going to use the power rule and the chain rule. So we're going to bring that 1/3 out in front times x squared minus 3x plus 2 to the negative 2/3. Right, so we took the derivative of the exponent. Now we take the derivative of the inside, which is 2x minus 3. I'm going to rewrite that a little bit before we find our critical values. This is going to be 2x minus 3 over 3 times x squared minus 3x plus 2 to the positive 2/3. You could also write this as cube root of x squared minus 3x plus 2 squared, but I'm just going to leave it as it is there. So once we have our derivative kind of simplified, written the way we want it, now we can find the critical values by figuring out when is the derivative equal to 0 and when does the derivative not exist. So for it to be equal to 0, we're just going to set that numerator equal to 0. 2x minus 3 equals 0. So x equals 3/2 is a critical value, as long as it works in our original function. If we put 3/2 in here, 3/2 squared minus 3 times 3/2 plus 2, we're going to get a number. It doesn't matter if that number is positive, negative, or 0. It works. We can take the cube root of a negative, a positive, a 0, any of those. So that's going to work just fine. We don't have to worry about that. To figure out when the derivative does not exist, we're going to set that denominator equal to 0. So 3 times x squared minus 3x plus 2 to the 2/3 equals 0. So we can divide both sides by 3, and we get x squared minus 3x plus 2 to the 2/3 equals 0. And then to get rid of that exponent, what do we have to do? Not multiply by 3/2, but you're on the right track. We're going to raise it to the 3/2, right? Which ends up, we multiply the exponents, but technically what we're doing is raising both sides to the 3/2 power, and then these exponents get multiplied, so we end up getting 1 for our exponent. So it's just going to be x squared minus 3x plus 2 equals 0. And that we can factor. This is x minus 2 times x minus 1. So we get x equals 2 and x equals 1 for our other critical values. And again, we want to make sure it doesn't mess anything up here. Like I said, we can put anything in this for x. Right? This is a continuous function. There are no holes, jumps, asymptotes, or anything like that. So these are all going to work. But you do want to check. Right? And that's one thing to kind of come back up here and kind of put a little star for this, for critical values. You want to check your answer in f of x. Right? You want to check and make sure that it works.